Have you ever wondered how scientists predict the spread of diseases, how engineers design roller coaster, or how Google AI learns? The answer lies in differential equations. In this video, I'll explain what a differential equation is, where we will use it in real life, and we will even solve a simple one problem together. Let's get started. So what is a differential equation? A differential equation is a mathematical equation that tells how something changes over time or space. For example, if you are driving a car, instead of knowing where a car is, a differential equation can describe how your speed changes over time. So we have a differential equation dx by dt equals to some function of x. This gives us the how the velocity of a car is changing. So if we integrate this, dx is equal to fx, sorry, this is the function of time, ft dt. So we will get plus c. X is equal to integral ft dt plus c. So we will get the function of speed. Similarly, if we differentiate it once more, d square x by dt square, so we'll get f dash of t. This will give us the idea about acceleration. The question might arise in your brain, why do we use differential equation? Why do we even need it? It is because the differential equations have application in almost every field. In physics, it is used in Newton's laws to describe motions, like how the planets move. In biology, it helps model population growth and the spread of diseases. In economics, differential equations help us predict how stock prices changes over time. In engineering, it is used in designing circuits, bridges, and even robots. Differential equation has its application in artificial intelligence and machine learning too. It helps in training model for different applications like self-driving cars. Now enough theoretical discussions. We will solve a very simple differential equation. That is dy by dx equals to 3x. So we will solve this using a very simple method known as variable separable method. So we will cross multiply this here. So we have dy equals to 3x dx. Now we'll put the integral sign. As we put the integral sign, we will put a constant of integration. This is very important because if we differentiate some constant with respect to t or x or any variable, we will get 0. So to compensate for this, we will put a c here, that is the constant of integration. So we have y equals to 3 integral x dx plus c. So integral of x to the power n dx is x of n plus 1 divided by n plus 1 plus c. So using this formula, we have y equals to 3x square by 2 plus c. So this is the final result. This is the solution of this differential equation. Okay, so let's study next type of differential equations. That is a homogeneous differential equation. We have all the terms in function f of x and y. They have the same power. So the general form of this differential equation is dy by dx equals to f of x and y. How do we check if a differential equation is homogeneous or not? So we have a procedure here, that is we replace x by lambda x and y by lambda y. We have a function here we will put lambda x and lambda y, and if we get the same function but with lambda raised to power some n, so this is how we check. For example, we have a differential equation dy by dx equals to x square plus y square by xy. To check whether this differential equation is a homogeneous differential equation or not, what do we need to do? We can take this as f of x and y. Okay, so in place of x and y, we will put f of lambda x and lambda y. So we will get lambda x whole square plus lambda y whole square divided by lambda x into lambda y. So we'll have lambda square x square plus lambda square y square divided by lambda square xy. So we can take lambda square common. We will have x square plus y square. In the denominator we have lambda square into xy. So I can cancel this. So we get the original f of x and y. So we have f of lambda x and lambda y equals to lambda to the power 0 f of x and y. Please do note that the n, this value n can be anything, that is even 0 also. 0 is also allowed. So this is a homogeneous differential equation. This is how we find out. So next we will see the steps to solve a differential equation, that is how do we solve a homogeneous differential equation. So number 1, we will substitute y equals to vx. This is step 1. Step 2, we have we will differentiate this equation with respect to x. So we get dy by dx is equal to, we will use the product rule here, v plus x dv by dx. Now we will rewrite this equation, or that f of lambda x lambda y, this equation in terms of y. So this equation will now get reduced to a simple variable separable equation. So let us solve this simple example on homogeneous differential equation. So let me rewrite this equation as dy by dx equals to x square plus 3y square by 2xy. So we have to substitute y equals to vx. So on substituting, we get x square plus 3 v square x square by 2x vx. So and here differentiating, we get dy by dx is equal to v plus x dv by is v plus x dv by dx, and we can take x square as common. So we'll have 1 plus 3v square divided by 2v into x square. Let us cancel this. So we have v plus x dv by dx is equal to 1 by 2v plus 3 by 2v. We have x dv by dx equals to 1 by 2v plus 3 by 2 minus 1 by 2v. So let us take 2 common. We have x dv by dx is equal to 1 by 2 common. So we have v plus 1 by v. We get 1 by 2 into v square plus 1 by v. On cross multiplying, we have 2x dv by dx is equal to v square plus 1 by v. So we get v dv is equal to by v square plus 1 equals to dx 2 is here, so dx by x. So let us substitute the denominator, that is v square plus 1 equals to 2. If we differentiate this, we'll get 2v dv is equal to dt. So we have dt here by v square plus 1 is t equals to dx by x. So we'll put integral sign here. We'll put a constant of integration ln t equals to ln x plus c. So let us substitute the value of t from this equation. We have ln of v square plus 1 minus ln x equal to c. We have ln of v square plus 1 divided by x is equal to, let us consider ln c as, let ln k equals to c. This is our consideration. We are doing this to simplify the equation. So we have v square plus 1 by x is equal to k. Now if we put the value of v, that is y is equal to vx, so v is equal to y by x. We will get y by x whole square plus 1 equals to kx. So we'll get y square by x square minus kx plus 1 equals to 0. So this is the final equation, and we are also given the initial condition, that is y of 1 equals to 1. So we need to substitute this and find the value of k and get a particular solution. So let us put 1 using y of 1 equals to 1. So if we put x as 1, we'll get y as 1. 1 square by 1 square minus k into 1 plus 1 equals to 0. So this is 2 minus k equals to 0. So k equals to 2. So putting this equation, we have y square by x square is equal to 2x minus 1. So y square is equal to x square into 2x minus 1. So let us study about the next type of differential equation, that is linear differential equation. Here y is the dependent variable and x is the independent variable. So a linear differential equation is a differential equation in which the dependent variable, that is y, and its derivative, that is dy by dx, appear only in first degree. That is, we have only dy by dx and we do not have d square y by dx square or higher other term. And they are also not inside any functions like sine dy by dx or log dy by dx or e to the power dy by dx. These are not allowed in linear differential equations. These are not allowed. Please also note that the dependent variable y and its derivative dy by dx cannot be a product term, that is, it cannot be multiplied together. It should be separable, like it is in case here. Also we have p and q, both are either constant or function of x only, that is the function of independent variable x. How do we solve a linear differential equation? So this is the standard linear differential equation. So we here identify px and qx. Then first step, we will find the integrating factor. So integrating factor is nothing but e to the power p dx. So this is the integrating factor. Now we have a formula here, that is y into integrating factor is equal to integral q into integrating factor plus constant. This will give us the solution of the above differential equation. But derivation of this formula is not required, as it is not asked in any type of examination. Okay, so let us solve a simple numerical to understand this topic in more detail. So we have a question, dy by dx plus sec x into y equals to 7. So let us find px, that is this term, it is sec x, and we have qx, that is 7. It is not a function of x, but it's constant. Okay, so next up we have to find out the integrating factor. We know the formula, it is e to the power p x dx. So px, we have sec x here. We know the formula, integral sec x dx is nothing but ln of sec x plus tan x. The integrating factor is sec x plus tan x. This is equation 1. Now we have found out the integrating factor. Next we will use the formula, that is y into integrating factor is equal to integral qx into integrating factor plus constant of integration. So y into sec x plus tan x equals to 7 into sec x plus tan x dx plus constant of integration. So we have y into sec x plus tan x equals to 7 constant, we can get it outside the integration. We have integral sec x dx plus 7 integral tan x dx plus c. Integration of sec x is ln of sec x plus tan x, and integration of tan x we have ln of sec x plus constant of integration.
Till my shadow turns to sun rays, and on